Anin, Bojo, Sarah Hazel Dijnakas, Nabizing Donjaba. Hello and welcome. My name is Sarah Hazel and I'm from Nipissing First Nation. I'm also the project manager for the Canadian Archaeological Association's working group on unmarked graves. Thank you for joining me today. I'm going to be talking about frequently asked questions about remote sensing applications. Before we get started, it is important to take care of yourself mentally and emotionally because unmarked graves investigations can bring up distressing content. Please make sure you have health supports in place, or you can call one of the numbers on this slide if you are feeling triggered and you can speak to a health professional. And I'll just leave this up for a moment in case you'd like to write one of these numbers down. The application of remote sensing is not necessary to know the devastating truth of the existence of unmarked graves of missing children in Canada and at specific Indian residential school sites. Remote sensing methods can sometimes be used to show specific locations of those unmarked graves. However, remote sensing cannot locate all the children who died at or went missing from residential schools. Remote sensing is only necessary should Indigenous communities wish to better identify the locations and distribution of unmarked graves to either protect and memorialize these areas or to conduct further investigations. This decision is entirely up to the respective communities to make without external pressure or interference. Remote sensing is a potential tool for finding missing children, but it should not be considered the first stage of any investigation. Several phases should be considered first, including, but not limited to, community meetings and investigation planning, archival research, and survivor interviews, which will all provide direction and potentially reveal important information about the location of unmarked graves. Likely, every investigation will be different because of many variables, including the number of communities involved, environmental factors, and financial support. Include the stages or steps that make the most sense for your situation. While the utility of remote sensing techniques in locating unmarked graves in cemeteries is well established, techniques for identifying unmarked burials are less well known, and the chances of success will be different depending on local geological conditions, land use, and vegetation. Communities should be aware that it is not possible to identify grave locations or the absence of graves with 100% certainty using remote sensing, though in some cases identifications can be made with great confidence. More likely, an archaeologist will assign different levels of confidence to the results in much the same way as a weather forecaster predicts the likelihood of rain. One way to increase confidence is to use different geophysical techniques in the same location, as complementary results from different approaches can improve confidence in grave identification. The greatest degree of certainty is achieved when a survey is followed up by excavation. However, full excavation of a potential grave location is not necessary. Excavation of the uppermost ground surface to expose the top of the grave shaft confirms the presence of a burial. Because this type of ground truthing disturbs the upper grave shaft, some communities may prefer not to pursue this method. It is important to remember that failure to identify graves with remote sensing does not necessarily mean that graves are not present. It can equally mean that the conditions were not suitable for grave detection with the remote sensing applications that were used. The conditions at the site will determine which type of remote sensing application should be used. Ground penetrating radar, or GPR, the technique used at the Kamloops Indian Residential School, is the most widely used and has the most successful track record for identifying unmarked graves in cemeteries. It has been used by archaeologists across the globe for decades. However, there are some conditions where this approach does not work well. Fortunately, there are many other techniques that can be used, including electrical resistivity or conductivity, magnetometry, and others that have also had success in identifying unmarked graves. While one approach might not be enough, the best results are often achieved when multiple techniques are used together, as each provides a distinct dataset that can offer different insights on features of interest and help confirm the presence of a grave, thereby improving confidence in the results. Establishing which approach is best should be done by a trained professional with knowledge of the specific site being surveyed in partnership with the local community. There are no physical risks to the graves or the individuals conducting the survey. In much the same way that navigational radar locates objects at a distance for boats or planes, archaeologists use geophysical survey techniques to see what is below the ground without needing to excavate, so there is no disturbance to the grave or surrounding area. Indeed, geophysical equipment used in archaeology is less powerful than your cell phone. The main risk is the potential for triggering and re-traumatizing community members, so it is extremely important that appropriate mental health supports are in place prior to work commencing. There is also the potential for disappointment and confusion should the results be inconclusive. While it is relatively straightforward to learn how to collect data using a GPR unit, the interpretation and analysis of GPR data is extremely time-consuming and requires specific training because the application of GPR to locate unmarked graves is uncommon. For instance, most remote sensing is conducted by companies working in industry, identifying utilities or surveying buildings and highways. Importantly, the identification of graves, both marked and unmarked, is usually conducted by archaeologists or forensic scientists. Unfortunately, some companies and individuals are seeking to take advantage of the tragic circumstances revealed at the Kamloops Indian Residential School by claiming they have the appropriate training and experience to identify unmarked graves. Therefore, extreme caution is needed. Communities who already have established and trusted relationships with archaeologists and/or forensic scientists should seek their advice before proceeding if contacted by remote sensing companies proposing to undertake such work. If you require assistance determining the best course of action for your community or communities, please email the CAA at unmarkedgraves@canadianarchaeology.com. Cost is difficult to estimate as much will depend on who does the work, the conditions at the site, the equipment used, and the intent of the survey. Communities may only wish to establish a cemetery's general location, known as reconnaissance, rather than determining the number and distribution of graves in it, known as mapping. The benefit of reconnaissance is that it takes less time, but this results in less detail. Oftentimes, it is most efficient to start with broad reconnaissance, followed by intensive mapping. Data collection with a GPR unit is much easier than processing, analyzing, and interpreting the information that is gathered through survey. Unmarked graves data is especially difficult to interpret due to the many unknown factors involving such burials. Therefore, the most time-consuming and expensive part of a survey of unmarked graves is analyzing the data and preparing the report. Permit requirements for archaeological or geophysical surveys vary greatly between provinces and territories and are also different for federal land, First Nations reserves, and Inuit-owned land. It is essential to check with your provincial or territorial archaeological body and the relevant Indigenous governments to see if you will require a permit for the work. If the site is located on private land, you will also need permission from the landowner. Miigwech, thank you for joining me for this video on frequently asked questions about remote sensing applications. For additional resources, please visit the web address located at the top of the slide. Take care.